to part 1 of modeling a parametric ceiling using data channel. In a new 3ds Max file, we are first going to create a cylinder to mimic our bamboo units for the cylinder. And then we're going to go quickly and adjust the radius to 0.04 meters and the height to be minus 0.5. So the ceiling is underneath our existing x-axis. And then change the default shading to edge frames and then remove our 5 segments to 1. And then moving on to the modifier tab, we are going to add array to our cylinder and change the distribution from grid to total dimensions. Make sure to select center so the numbers you are feeding are read center to center. And let's change the count of x and y to be 20 and width to be around 6 meters. And back to the modifier tab, let's add data channel. Make sure you have enabled display to see all the changes parallel to your operators. First, we're gonna add distort from our operators list. And it says here to use a map to distort the vertex values. So we're gonna go and add our map here in no map. We're gonna open our material editor and add a noise map to the screen. And then we are going to go ahead and plug that into our map, and it says instance is okay. So you can see that there's a direct change on our ceiling, and we are going to change the scale to, it's at 25. You can keep it at 25 for now, I guess, and then change octave to 1 and close it. And then you can see how the noise map is implemented on the ceiling. Opening our operators list, we are then gonna add from our output operators the vertex output. Here you can always read the operator input underneath. It says to stack data to a specific geometric channel. And we are gonna go ahead and add that. And here you can see after adding it and scrolling down in the vertex output, we're gonna make sure that it's at position and add the z-axis. Going back to the distort level, we're gonna go to display. So this is the color information, so it gives you the minimum values in blue and the maximum values in red. And then go ahead and select normalize display. And then zooming in here, you can see the 3 colors according to the overlaid noise map. And then we're gonna add a scale between the distort and the vertex output. It's like Photoshop, you have to layer your layers. And then change the scale to 150, so you can see it directly changes the ceiling. And we can open our material editor and sort of play around to get a shape that we would like for our ceiling. So you can change the octaves and the gain and even the low and the high points of the ceiling. So you can manipulate these numbers until you are sort of satisfied with the shape of the ceiling. So I'm gonna go with 20 octave so far, and then low to be 0.6 and high to be 0.7, gain being 0.5, and that's the sort of shape that I have ended up with. but you can see when I zoom in, the ceiling is actually cut at an angle. So we're going to sort of fix that and make it again a clean cut at the edge. We're going to go back to operators and then put geo equalizer on top of the scale, and it immediately shows you the results. Now it's again back to our cylinder units. You might be able to sort of increase the units for these ceilings. So I'm going to go ahead and fix my array to 30 by 30, and this makes the ceiling look more full, I guess, and it sort of showcases your noise map better. That is it for part 1. I'll see you guys soon in part 2. Thank you for watching.